Math is a wonderful thing. Math is a really cool thing.
For section 7.4, we are going to learn how to graph systems of inequalities. So graphing a system of inequality is fairly simple. We just have to graph each inequality, and then we are going to identify the overlapping area of the two inequalities. So let's start by graphing our first inequality. So we know that the slope is 1/2, or we can say -1 over -2, and our y-intercept is equal to 2, 0, comma 2. So start on this point. So this will be our first point. Next, let's find the other point by using our slope. So we have 1 up, then 2 to the right, 1 up, 2 to the right. Or we can also use -1 over -2, down once, and then 2 to the left, down once, and then 2 to the left. Next, since we have here a line under, the line that we are going to use to connect these points should be a solid line. Next, we have to decide if we are going to shade above or below this solid line. Since I have y less than, using the shortcut, we have to shade the area below the line. Alright, we are done with the first inequality. For the second inequality, again, we have to identify the slope, which is 3 over 1, or you can say -3 over -1. Our y-intercept is equal to -3, so we are going to start our line here. Slope is 3 over 1, so go up 3 times. 1, 2, 3, 1 to the right, 1, 2, 3, then 1 to the right. Now, since I don't have a line under, the line that I'm going to use here is a dotted line. Next, since I have y greater than, we are going to shade the area above this line. Alright, next, we are going to identify the area where the two inequalities overlap. So the overlapping area is over here. Okay, so I will shade this area, and this will be our solution set. Now let's try to answer the following questions. Is the point -2, comma -2, which is located here, a solution to the system? Since this point is on the intersection of the two areas, we are going to say that -2, comma -2 is a solution. What about 1, comma 0? So 1, comma 0 is over here. Now, since this point is on the boundary line, and this line is not a solid line, we are going to say that this point 1, comma 0 is not a solution. Same thing with this point over here. Now this point is on the intersection of the two lines, but one of the lines is not a solid line. So this point, which is 2, comma 3, is not a solution. But if we are going to choose this point, for example, okay, this point is also on the boundary of this area, but the line where this point is located is a solid line. So we are going to say that this point, which is 1, 2, -2, comma 1, we are going to say that this point is a solution. In general, all points that are on the overlapping area of the two inequalities will be a solution set, including on the boundaries that has a solid line. So all the points here will be a solution, including all the points on this area. Again, if we have points on this boundary, we are not going to consider this as a solution to the system. All right, example number 2. I need you to pause the video and graph the system of linear inequalities. All right, next example. Let's try to graph this system of linear inequalities. All right, this time we have 3 inequalities. First inequality, we have x greater than or equal to 0. We can use our shortcut VUX. So it's a vertical line that will pass through the origin, and that line should be a solid line because we have a line under. So let's graph x equals 0. So this should be the vertical line crosses the origin. Now this one is x greater than 0. So we have to shade the right side of this blue line. Okay, next, let's graph y greater than or equal to 0. Again, we can use the shortcut HOY. It should be a horizontal line that will cross the origin. And since we have a line under, it should be a solid line. Next, we have to decide if we are going to shade above or below the line. Since we have y greater than 0, we have to shade above the line. So I'm going to shade this area right now. All right, from the 2 inequalities, we can say that this area here, the 2 inequalities did not overlap on these areas. Okay, so they only overlap here. It means that when you include your 3rd inequality, the intersection of the 3 should only be within the overlapping of the first 2 inequalities. All right, let's try to graph y equals negative 5 over 3x plus 5. The slope is negative 5 over 3 or 5 over negative 3. My y-intercept is 5. So 1, 2, 3, 4, 5. So this will be our first point. I'm going to use this as my slope, negative 5 over 3. I have to go down 5 times. 1, 2, 3, 4, 5. And then go to the right 3 times. 1, 2, and 3. Okay. Now since we have a line under, I am going to use a solid line to connect these 2 points. All right. Now we know that the overlapping of these 3 inequalities should only be located on this area. Okay. So we have to decide if we are going to shade above the black line or below the black line. Now using the shortcut, since I have y less than, I have to shade this area. Any point on this area will be a solution of this system, including points that are on the boundaries. Okay, since we all have here solid lines. So let's answer the following questions. Is 1, 1 a solution? Yes, it is a solution. 2, 0. Okay, since this point is on the boundary and this line is a solid line, we are going to say that yes, it is a solution. 1, negative 1. So 1, negative 1, for example. Okay, this point is not on this area, so we are going to say that 1, negative 1 is not a solution. All right, example number 4. Pause the video and try to graph the system of linear inequalities. Our next problem, again, we have here 3 inequalities. We are going to get the overlapping area of these 3 inequalities. Note that the first 2 inequalities are given in standard form. So we can rewrite each of these into the slope-intercept form and graph each inequalities. But what I'm going to do right now is to use intercepts to graph 2x plus y less than negative 3. So if x is 0, y is equal to negative 3. So that's our y-intercept. And then if y is 0, x will be equal to negative 3 over 2 or negative 1.5. So 1, negative 1.5. Now going back to the inequality, we don't have a line under, so we are going to use a dotted line. Right. Next, to decide if we are going to shade below the black line or above the black line, we can't use a shortcut here because I have the standard form. We are going to use a test point. So let's use 0, 0. So 2 times 0 plus 0, is this less than negative 3? So is 0 less than negative 3? This one is false. So 0, 0 should not be shaded. Since 0, 0 gave us a false statement, we have to shade the other side. So we have to shade this portion. Alright, next for 2x minus y less than or equal to negative 1, again, I am going to use intercepts to graph the second inequality. So if x is 0, y will be equal to positive 1. So we have 0, 1. If y equals 0, x will equal to negative 1 half or negative 0.5. Next, since we have a line under, I'm going to use a solid line to connect these 2 points. Now, to decide if we are going to shade above or below the blue line, we are going to use a test point again. So let's use 0, 0. So 2 times 0 minus 0 is actually equal to 0 less than or equal to negative 1. But this one is a false statement. So we have to shade the other area. So I'm going to shade here. From the two inequalities, we can now cross out the area where the two inequalities did not overlap.
So no overlapping here, no overlapping, cross this one out.
Okay, so the two inequalities only overlap on this area. So when we include the third inequality, the overlapping should only be on this area. So this one is x greater than negative 3. It is a vertical line, VUX, that will cross negative 3. So 1, 2, 3. And since we don't have a line under, it will be a vertical line that is actually a vertical dotted line. All right. And then it's greater than, so we have to shade the right side of this line. Okay. But we know that this is not part of our solution. So we are going to say that the intersection of the three inequalities will be on this area. Okay. So let me make this a little bit darker. Alright, so this will be our solution to this system of inequalities. Now let's answer the following questions. Is negative 2, negative 1 a solution to the system? So negative 2, 1, 2, and negative 1. Okay, this is a solution. Yes. Negative 2 and negative 3. 1, 2, 3. Okay, it is on the boundary, but this line is a solid line, so we are going to say that it is a solution. Negative 1 and negative 1. It's also on the boundary, so this point is located on this solid line and on this dotted line. Now, since we have here a dotted line, we are going to say that it is not a solution. We are going to say that this will be a solution only if it is on the boundary line, and both lines are solid line. Alright, so there we go. This is the answer for problem number 5. Alright, problem number 6. Let's find the graph of this system of inequalities. So we have y greater than x. Slope here is equal to 1 over 1 or negative 1 over negative 1. And the y-intercept is equal to 0. So starting here, and go up 1, then right 1, up 1, right 1, up 1, right 1, up 1, right 1. Or go down once, left once, down once, left once. Alright. Now since I don't have a line under, this should be a dotted line. Next, it says y greater than x, so we have to shade above this line. Next inequality, slope is 5 over 1 or negative 5 over negative 1. Y-intercept is also equal to 0. Let me use another color. Starting on the origin, then go up 5 times. 1, 2, 3, 4, 5, and 1 to the right. So connecting these 2 points, we have to use a dotted line because we don't have a line under. Okay. Next, this one is y less than, so we have to shade below this line. So below this line means over here. Okay, so let's cross out the areas where the 2 inequalities did not overlap.
So we don't have any overlapping in here. No overlapping here. Okay.
So the 2 inequalities overlap on this area. Now let's include the third inequality. X less than 2. So this is Vox. It's a vertical line that will pass through x equals 2. And again, we don't have a line under, so it will be a vertical line that is a dotted line. Okay, and it says x less than, so we have to shade left side of this red dotted line. Since we know that the intersection or the overlapping of these 3 inequalities will just be confined on this area, when I shade the left side of this red line, I'll just shade this area. And this will be our intersection or the overlapping of the 3 inequalities. So all points on this boundary line will not be a solution to the system because we have here a dotted line. Same thing here, all points here will not be a solution because this line is a dotted line. Similarly, all the points on this boundary line will not be a solution because we have a dotted line. So it means that the point, in order to be a solution, should be on this shaded area. Okay, that's our problem number 6. Alright, problem number 7. I need you to pause the video and try to graph the system of inequalities.
Problem number 8. Select all points that are not part of the solution set to the system of inequalities shown in the graph. Remember, should not be part of the solution set. Let's try 1, 2. So 1, 2. So this is a solution. 2, 3. 2, 1, 2, 3. This is also a solution because although it is on the boundary line, this line is a solid line. So this is a solution. 1, 4. 1, 1, 2, 3, 4. Okay, this is also a solution. Negative 1, 3. So negative 1, 1, 2, 3. So this is not a solution. So we are going to select negative 1, 3. 2, 2. Alright, this point is on a solid line and on a dotted line. Therefore, this is not a solution. So we are going to choose 2, 2. And then 2, 5. So 2, 1, 2, 3, 4, 5. Okay. Also, this point is on the boundary line, and this line is a solid line, so we are going to say that this is a solution. So we are not going to choose this.
All right, that's your problem number 8. For problem number 9, since we already have the system and we are trying to identify points that are not a solution, instead of us graphing the system, we can just plug in each of these points. So let's say for 1 comma 2, so let's plug in x is equals 1, y equals 2, is 2 greater than 1? Okay, that's true. This is 2, x equals 1, is 2 less than 5? That's true. And finally, is 1. So x is equals 1 is 1 less than 2. That's also true. Since this point, after plugging in this point to this system, we were able to get 3 true statements. Therefore, this is a solution.
This is not one of our answer. Okay, next. Let's plug in 2 comma 3. Again, this is my x and this is our y. So, is 3 greater than 2? Alright, that's correct. Is 3 less than 5 times 2, which is 10? Yes, 3 is less than 10, so this is correct also. Is 2 less than 2? So this one is false. So we are going to say that 2 comma 3 is not a solution. Next, 1 comma 4. So again, x equals 1, y equals 4. Is 4 greater than 1? Okay, that's true. Is 4 less than 5 times 1? Yes, that's correct. And then is 1 less than 2? So this is correct. So this is a solution. But remember, we're trying to find points that are not part of the solution set. Alright, negative 1 comma 3, this is x and this is y. So is 3 greater than negative 1? Okay, that's correct. Is 3 less than 5 times negative 1? No, because this one is negative, so 3 should be greater than negative 5. So this one is false. Since we have a false statement, we are going to say that this is not a solution. So we have to choose this as part of our answer. Alright, next point, 2 comma 2. So x equals 2, y equals 2. So is 2 greater than 2? Well, this one is false already because we cannot have 2 greater than itself. Okay, so this is not part of the solution. What about 2 comma 5? Again, x equals 2, y equals 5. Is 5 greater than 2? That's true. Is 5 less than 10? That's correct. Is 2 less than 2? This one is false. Since I have one false statement, we are going to say that this is not part of our solution.
Alright, so comparing problems 8 and 9, if we have a graph, so just try to plot your points and identify if it is a solution or not a solution. If you don't have a graph but we have the system, well, I would suggest just plug in all the points and identify which are not part of the solution in order to answer this question.
Math is a wonderful thing. Math is a really cool